All right. Okay. So let's get started. So the concept that we are going to talk about now is called version control. Okay. So the idea, of course, is something that every programmer will have a requirement because every programmer knows that each time you save, every save is basically effectively a new version of the code. Okay. Now, one technology which the programmers have started using whenever there are different versions is the concept of make. Okay. So, but that is basically to compile only those parts of code that have changed. Okay, so that allows for at least that as you keep writing your code and modifying, you don't touch what has not been modified. So it is compiled and that's it. You don't have to go back to look at it. Okay, so that way there is some discipline about going about programming. Now, but still, this is still in a regime where there is only one person. So there are requirements. Then, when there is a group, so let us say a group of programmers are working, and they are working on a major project. So you basically think of a mega project. Okay, and of course, it entails that there will be lots of codes, and that we would like to also would like to think of it as implying that lots of files because you know that we are going to have a modular approach towards making our program. Okay, so if it is a modular approach, then our code will be broken down. So typically we would like to have one file per function that we are writing in the program. So we are talking about it as a C program or C++ program. Then we would like to have in a C++ code, of course, you would like to have a class in one file, and in a C language, you would like to have each function as a separate file. Okay. So that once you're done with the function, and you don't have to go back to it. And why we would like to have a lot of files is because, of course, there's a group of programmers. So each programmer can volunteer to work on a particular function, which means it's a particular file. So there is a tacit understanding that the rest of the programmers are not going to touch it at the same time, typically. Okay, and therefore they are able to work together. Okay, so naturally, so you'll have a situation where each programmer has, let us say, multiple versions of each file they worked on. Okay, so there's not just one version per file, but every file that they are saving, if they are saving 10 times a day, it means that there are 10 different versions of that file, and over the programming duration, there will be a large number of versions. And why is the version control necessary? Okay, so the version control essentially is to trace back to a working version of code. Okay, so that's the idea basically. So you have made some changes, so it seems to work fine, and then you made one more change, everything broke. So naturally, the first thing that you would like to do is just go back to the version that worked fine, and then continue developing by not making the same mistake, but making maybe different mistakes. Okay, that's how life is. But of course, we keep improving always. We have learned from our mistakes always, and we improve. And that's how we basically create new versions. So the ability to trace back to a working version of a code is must. Now you can see that this entire scenario entails that the version are going to be like number of users into number of files into number of times you have got the versions. So that will be quite a large, and you need a database to hold this info. Okay. So you because there are a lot of files and there are a lot of users and there are a lot of versions for every file, and therefore there is a way by which you have to supposed to see keep track of all these things, and therefore we have a requirement to keep it in a good database. Now there are some methodologies that were followed in the past to go about this process, and I would say there are two ways of handling. So you can think of these major categories as, for example, one is called SVN. Okay, so source version controlling system, and you can think of it as a centrally hosted and managed version system. Okay. And of course, we also have Git, which is basically distributed. Okay, uh, version control system. So, so that is a major difference. Okay, so the difference between these is it central or is it distributed? Okay, of course there are people who still use SVN, but there are two major categories that people use, and there are pros and cons. Okay, so SVN allows for one master who actually keeps track of what is the version of the code that we are actually officially supporting, and therefore the master is then going on to essentially ensure that the same version is replicated by others, and therefore whenever any person has any doubt about that code, you can just go to the master server and bring the version, and then you know that there's a version that everybody is supposed to have. So there's a certain amount of simplicity and clarity that is there in this approach. But of course, the programs have all to be saved on some storage systems, and you know that typically the storage systems when we talk about their failures, typically we don't say for storage systems, you don't say, if it fails. No, what we always say is when it fails. So what does it mean? It means that the storage, there is no uncertainty that it will fail. Okay, it will definitely fail because there are moving parts and there is some heat generated, and therefore definitely there are going to be failures in the hardware. So the problem, our analysis should never be if it fails, because the if is not a possibility of probability, because the probability is 100%, because it's only a matter of time, and therefore you are supposed to ask when it fails, what would we do? So in that situation, if you have a master server on which the code is stored, then when it fails, you have a problem. Okay, you have a problem because the entire software is down. Nobody can actually access what is the master version of the source code. Of course, people can take into account that the storages can be failing, and therefore they may have multiple storages, and they may have a way by which if one hard disk fails, the others are also able to chip in. Okay, so does anybody know? I mean, this is something that I want to have a little bit interaction. We are going quite fine with the syllabus. We are going to finish quite soon. So I want to also sort of finish up some loose ends as I go along. Okay. So upon Janmejaya, we will come to the concept of branch. We will come to it a little later, because the idea of a branch exists only in Git. Okay, not in SVN, because in SVN the concept, the word called branch has no special meaning like the way we talk about it in Git. Okay, because it has a much more connotation. There is a lot more to it. The word is a very loaded word, so we'll come to it in a moment. Now I want to ask you, what is the technology used by people around the world to ensure that if one hard disk fails, it doesn't actually fail the storage, that you are still able to access the file? Can somebody volunteer and say what that could be? Anyone? I'm sure in a large class like you, almost 50 students around, definitely there'll be one person who has heard of it. Backup is a separate matter. Okay, so you can always take a backup, but when the server, crashes, I mean the storage box crashes, then it is down. So what I'm saying is that if there is a hard disk, you see, if each hard disk is a separate, hardware entity. It's a unit that you are going to plug in and give power. So if that unit actually fails, you don't want the ability to access your file to be lost. Backup is always something like, when you have burnt your hands, you go and apply some ointment. It's like that. The problem has already occurred, and then you go and see mitigate the problem to the extent by bringing up a version that was there earlier. That is something, secondary. But to even avoid hardware failures, what's the technology that has been in place for the storage systems across the world? And it's a standard actually. No, nobody yet. So I will give you a clue and I will ask you. Okay, so what is this? Anybody knows what is RAID? Shoban says yes. Okay, now go ahead and tell Shoban. What do you know about RAID?
So, RAID is the old version. Do they still use it? RAID?
Yeah, of course, there are multiple versions of RAID. So the number that follows RAID, RAID 5, RAID 6. So that versions are always there, but the idea of RAID is something that I want you to be aware. Okay, let's go ahead and then look at it quickly because I don't want again to take too much time. So I would say uh, RAID for uh, storage. Okay, I'll just tell you what those numbers are. That's all. Okay. So RAID is basically a way by which you would like to have a redundancy. Okay. So that means you would like to have uh, a copy of your file in multiple disks so that if one disk fails, you still have file available to you. That was the idea basically. And obviously you should have multiple disks because you are talking about if one disk actually has a problem, there is another disk that is responding to you. So that means there must be multiple disks, and therefore that is the idea of array. Okay, so the concept of array is because you need multiple disks. Okay, and in terms of the second, third letter I. So is it independent disks or inexpensive disks? Of course, it's up to us for us to interpret. But it's now today RAID is actually almost like a word. I mean, people don't expand it. Okay. Now there are different versions of it. Okay. So here you see RAID 0, RAID 1, etc. Okay. So each version has certain names. Okay. Now the idea of RAID 0. Okay, you can just see the here. Okay. So what the RAID 0 is basically to ensure that you have a large disk and you don't have one disk that can have that same capacity, and therefore you would like to have two disks that are kept one after other. Therefore, you have got ability to have a larger disk. So let us say you wanted a 20 TB disk, but in the market there are only 10 TB disks, so you can get two of them. Now, one thing I want you to also remember is whenever you have an array, it also means that speed up. Okay, so whenever you have got any file that is actually stored over multiple disks and you are going to read it, so each disk can respond for different parts of the file, and therefore you actually can get faster speed. Okay, so this is not only about the redundancy, but it is also about the speed. Okay, so okay, both are necessary. Okay, now what is the kind of speed we are talking about? Okay, so for SATA disks, uh, 6 GB per second is what we are talking about. And let us say you would like to have jacked up, let us say, to 18 GB per second. So you can't actually go and buy a faster hard drive because they just simply don't exist. So the way to achieve is because you have a concept of RAID. So you can put multiple disks, and therefore when you are reading a file, it can actually come from three different disks. Three parts of the file can come from three different disks, and therefore the effective speed that you are gaining from the system is actually 18 Gbps and not 6 Gbps, and therefore you are actually getting the speed up. So this is also a important feature of this technology. Now, as your colleague Shobhan was asking about the version old and old technology, etc. So here, RAID 1, for example, is today a very continuously being practiced version of RAID, and that is because you have got mirroring. Okay, now which means that in fact in my computer I have got two hard disks of 500 GB each, which are basically in RAID 1, which means that if one of them goes off, then other disk is there. So I am free from the failure of hard disk. Of course, the probability of two disks simultaneously having a problem is very rare, and to that extent, I am actually having safety. Okay, so Janamaji is asking about the actual disk or virtual partitions. They are actually on disks itself. Okay, so once the disks are actually made as RAID, then you create a volume, logical volume, and it is a logical volume that you see as a partition. So think of the partition is as a abstraction level that is after RAID has been configured. Okay, so it is not before, but it is after. Okay, now there are some RAID options that you may be interested. Okay, so today RAID 5 and RAID 6 are quite popular. Okay, so RAID 5, which actually has both distributed as well as some amount distributed parity as well as some striping. What it implies is that when you have RAID 5, when you do on 3 disks, it means that if one disk goes off, absolutely there is no loss of data. Okay, there's no loss of data. Okay, and you can also get the speed up because the file is coming from 3 disks instead of one disk. So today we have got RAID 5 and RAID 6 very popular to have these things. Higher versions of RAID are also available. Okay, and there are much larger concepts of it when you go to huge storages like petabyte storages, etc., where they have got Hadoop and distributed storages, etc. And what I want you to know today is that when it comes to this, when it fails is sort of addressed by RAID. That's what I wanted you to have heard of it. Okay, it's addressed by RAID. So when you buy a workstation, just check, does it contain a RAID controller? Okay, so there is a card. Okay, there is a PCI card which is called as RAID controller. Okay, and this controller will have a particular speed. Okay, and that speed actually tells you how fast you can get the data. And so and also it will tell it will have a capacity of how many disks it can actually talk to. Okay, so for example, my workstation is a small workstation for my office, so it has about 8 disks that it can talk to. So I have populated all of the 8, and I have got what is called as a hot spare. A hot spare is basically a disk which we keep plugged in, but it is not being used. So if any of the existing disks fail, then automatically the hot spare will be put to use, and I will have an amber light on the failed disk, so I can safely take it out, and the hot spare actually be now configured in automatically so that it's participating in the shared storage of the files. Okay, so we can't plug out the disks randomly. Once we configure them in a RAID, we have to not touch them, and whenever there's an error, we have to immediately replace the disk. But if you do that, advantage would be that your storage can actually live for very long, because as disks fail, you can keep replacing and your data is never getting lost. Because think of it like this, so it's like this: you have got a file, so you make it as 2 parts, 3 parts, and let us say you have got the storage in this manner. Let us say, so 4 hard disks. So I will put part 1 here, part 2 here, part 3 here, and what I will do, I'll put part 1 here also, and I put part 2 here also, and I put part 3 here also. Now you see that I have got okay, if let us say this fellow goes off, then I have got 1 here, 2 here, 3 here. Okay, and let us say if this fellow goes, then I have got 1 here, 2 here, and 3 here. Okay, and let us say I have got this fellow going, I have got 1 here, I have got 2 here, I have got a 3 here. Okay, And then let us say if this fellow goes, then I have got 1 here, 2 here, 3 here. So you can see that, I mean, this is a very simple, illustration to show you that if I just divide it by 3 parts and arrange them in this manner, if one of the 4 hard disks fail, I have no problem at all, because I have got portions of it in other hard disks, so I can recoup. So if one of them fail, I can replace it with a fresh hard disk, and then the system will automatically know which part actually has been replaced, and it will go on to write that part alone, so that the RAID configuration is back to normal. So which means that the hard disks are actually live, they are being written all the time, and the computer is analyzing which part of which file is in which hard disk, and ensuring that that particular hard disk is alive, and there are at least 2 copies of every chunk. Okay, I won't say 2 copies of every file, but 2 copies of every chunk. So which means that which actually means that in a RAID, okay, RAID config, usable space is less than actual space. Okay, so for example, if you have got 4 into 8 TB disks, you have 32 TB disk space, but when you configure as a RAID 5, you may have about 26 TB or so. Okay, so the remaining data is lost because you are actually repeating some portion. So about 1/3 of what you have stored is actually repeated, and therefore you can't have that. But that comes with a positive thing that one hard disk crashes and you have no problem. Okay, so much about RAID, and go on to read about it for your own benefit. I don't need to talk about that. Okay, so next we'll go and say, okay, now this hard disk failure is not a problem. We have controlled it. But what happens when the server itself is hacked and actually there's a data loss? Okay, so therefore SVN has that still problem. Okay, because it may actually still keep the data, but if somebody hacks in and wipes off, then you have a problem. Okay, so for that, the Git actually has a very good idea, because it is distributed. Okay, so which means that if the master, I mean, if at all, if you want to call something as a master, if the master server is actually suddenly disappeared from the face of the earth, nothing is lost, because what this implies is that every user, okay, or I would say collaborator, has a copy of everything. Okay, now obviously program codes are not very large, so therefore it doesn't actually take so much of space. We are talking about maybe a few megabytes and maybe 100 MB of your programming codes, and therefore it doesn't matter if everybody has a copy, but it gives a redundancy, and therefore if any user wants to go on independently, they can actually start from where they were and then start a new thread, okay, and a new version of that particular program, and you can think of it as a fork, okay, or a new branch. Okay, so both are having technical differences. We'll come to that in a moment when we actually use. So a user can actually go on to have their own version of developing things independently, and therefore that also is more democratic. So Git is that way a more preferred way of going about. Now it also doesn't really require a server. Okay, the Git system doesn't require a server, because yeah, when you are alone, you yourself can use Git, and you can just simply have the version control within your own machine, and you are the only person, and that's all it is. Okay, so that's also possible, but it's a good idea to also have some server. Okay, now the Git system is open source, which means that you have got the Git system enabled for all operating systems, and you also have some free software, free servers that are allowing you to use it as a one of the synchronizing remote spots. So in Git system, there is some concept of remote. So that means that it is basically some server with which we basically sync. Okay, of course there is no need to do that, of course, but we want to sync because we would like to together maintain some master version. To that extent only we want to sync up, but each user has a copy. So that's the idea. Okay, so it's still not as if the remote machine is down, you don't have access to the master version. That's not true. Okay, so you have got the version with you, at least as on the last synchronization that you have done. So by remote, we mean a server with which we try to synchronize. Okay. Now there is a way by which we connect, and the protocol is what is called as the Git protocol, and that is now, because it's open source, it is now adopted by people across the globe, and therefore there are many things that actually use the concept of Git, but do totally different things, very unlike a programmer also. Okay, that's also fine. There's no problem, because it's actually a protocol by which you are actually exchanging information with a remote. Okay, and also keeping the version control. That's the only two aspects of it that we need to basically think of. Okay, now you can have many different options of using it. So one, of course, is locally run Git server. Okay, you may have, for example, a campus Git server. Okay, you may have a GitLab. Okay, some remotely hosted Git server, or you may even have GitHub.com. Okay, now I prefer that you start getting used to the GitHub.com for multiple reasons. One reason is that it actually is a cloud, and which means that you don't have to worry about how it is storing files and who is paying for it, etc., because it is basically taken care by Microsoft, and the files are all meant for public good of whole world, because it contains a lot of free software that people are actually using to share, and all that is actually going to be there. And they also have taken a copy of GitHub as on last year and kept it in Arctic vault, in an underground storage system, so that even if there was a huge bomb attack on the data centers in America, you don't still lose your files, because there is one copy of it somewhere kept aside. Okay, so for the future of humanity. And so there are all those kind of things that can be done by a company, and that's what is the advantage. So starting to learn to use Git with GitHub.com has some specific advantages. Okay, now there is other things that I want to also tell you why you should learn, is for this, that now GitHub.com insists from August 11th onwards, I think. Okay, I think concept of two-factor authentication. Okay, so have you heard of two-factor auth? Anybody wants to tell what is two-factor authentication? You may have done it already for Google account, because it's a good habit actually, so that you don't lose your password easily or lose access to your account easily. So anybody wants to tell what is two-factor authentication? Raghvani may be knowing it. So Shobhan says you need another verification to log into the account apart from password. Yeah, that's about it. Succinctly, that's all it is. So there must be one more way. Okay, so what does it mean by one more way? Okay, so this is all. Okay, you may have an app, and it will be telling you some OTPs, and that you need to enter. Okay, or you may have an app that will ask you, and you swipe and confirm. Okay, and or you may actually have an SMS that is coming to you as an OTP, and that you enter. Or you may have an email which actually contains the OTP, and that you enter. Or you may have a set of codes which you actually use it to enter and then authenticate. So set of codes which are somewhat like recovery, etc. Okay, and whenever you say an app and an OTP and all that, so most of these things, for example, up to here, you have a phone, okay, number involved. So which means that there is a certain way by which we are trying to see who is the person who is actually using this account. And that person is identified by the phone number uniquely, because you are sending something and somebody is checking that number and entering, and it is being done in a way that requires some amount of human action. Okay, so preferably, and okay, so that is one way by which you can actually ensure. So you don't lose both. So you don't give away your password, and also you hand over your phone to somebody. So anybody who knows your password and has your phone is basically you. Basically, okay, it's as good as you, and therefore that's like total loss of identity, and we don't do that. So we have only one of them losing at a time, and the immediate other one is blocked. Okay, as soon as you lose a phone, you go and go to the app and in the website, and then tell that my phone is lost, or you just simply change the phone number to something else, and therefore the person who happens to gain access to your phone doesn't have actually ability to mimic who you are, okay, on the things on the internet. Okay, so this is the idea. So the two-factor authentication is a must. What we mean by a must is from August onwards, it's a must. Okay, so by that we mean that you simply cannot have only the password to actually authenticate. You must have two-factor authentication enabled, and you should use it while doing some actions on the command line, and that is good. So one of the things of all these is that you also have it, the second factor authentication is sort of customized for each I would say repository or activity. Okay, so why I say activities? Because in Google, for example, if you are going to have an account for each machine on which you are going to have the authentication happening, for example, you are configuring Thunderbird on your machine, and you are going to talk to your Google email account, then you can actually have a what is called personal access token. Okay, PAT. So you can have your token, which is basically a long string. Okay, it's basically a string, and you can use that string as a password. Okay, and you can actually have that specifically for certain activities in the case of Gmail, or for repositories in the case of GitHub, so that you do not actually have the same thing for multiple repositories, and therefore if you lose, you still don't need to worry about it much. It doesn't cause so much of damage. Of course, you can immediately go and block access. That is always there. You can always revoke. Okay, so these tokens can be revoked in a click. Okay, and that is what is actually gives you safety. Okay, so if you lose something, doesn't matter. You can always revoke the privileges and go ahead. So I want you to know about this and go ahead and actually log into GitHub and start doing it. So the activities I would like you to do are, I would say, log in. Okay, please go and register yourself on github.com. And of course, next step I would like you to do is that enable two-factor authentication. And of course, you need some way of enabling. And I would say for my side, I would say prefer Microsoft Authenticator app on Android, and that will give you those OTPs, changing every minute, okay, to enter, okay, when you need to log in. Okay. So I'll do the demo of it in a moment. And of course, once you do that, of course, you need to create a repo, and you need to practice how to pull, push, okay, and do all the Git actions. Okay, so we will do that. Okay, we will do all of this in a moment. Okay, so I think there are not too many students who have been using Git. So if somebody is actually started to use Git, then I would like them to share their screen so that I can actually navigate and show where the options are. Okay, so I just simply now stop presenting, and I'll ask one of you who has a GitHub account to see. Okay, so can you share anybody who has a let me just see anybody volunteer to show their ability to log into github.com. I don't expect every one of you to do it, obviously, because then I don't need to have this session. But I am sure that in 50 students, there'll be at least one who would have already started to use Git. So anybody who has used Git, Raghavan is good. Go ahead, go ahead. So we also discussed that we would like to have you do that. So go ahead. So share a screen browser. Okay. Yeah.
I have just created the account. I don't know how to use it.
No problem, no problem. That's what I would actually guide you. So on the right hand side top, there is your photo. Okay. And that when you click on it, there are a bunch of things that are coming up, right?
Yes.
So go, yeah. So go down to settings. Okay. Now on the left, you can scroll down and okay, developer settings. Just click on the developer settings. So then personal access tokens is there, right?
Yes.
Click on it. Okay. So now we need to basically create a new token, and with that you can actually go ahead and use it. Okay. So you can click on that to generate a new token. There's an icon there, right side, right top. So obviously it is asking you to log in once more or confirm who you are. So now you need to describe what is this token for. Let us say, okay. So you can say, a course demo or something like that. Okay? Let us say course demo. Okay, and then you have to tell what are the actions for which you are going to use this token. Now you see, this is the place where you are controlling what actions are possible for each of these, tokens. So the token that you are giving, you don't want to do anything about the administration or deleting, etc. Nothing. So you just click on that repo, the very first box. Okay, and obviously it has got a lot of actions, 5 of them. So even you can even remove that repo invite from there. Okay, so you don't need that because you're not going to invite others as of now. Keep it. Okay, fine. Okay, leave it. Okay, now you have come down and you can. Okay, this is sufficient. There are a lot of actions that are possible, and you can say generate token. Click on generate token. Okay, now be careful. Okay, now everybody is seeing this token, so it's okay, doesn't matter. We are all only learning. So if you click on that keyboard icon, which is if you click on it, it will copy. Okay, copy it and immediately open a text file and save it to the text file so that you have, you don't forget it, at this moment. Okay, so you can open a VA editor or you can text file. You can just open VA editor, save it. Okay, so normally I would actually call that as a PAT, a file called PAT. It's a personal access token file, basically, in which I can just have that thing. Okay, so VIPAT. Okay, and then you put put I, and then now just go above one, Shift O. You press Shift O. Shift capital O. No. While you are in the VI editor, Shift O. Don't insert. Okay, just escape. Okay. Now you write what was this meant for. So you said no course demo.
Yes.
Write that name there. So you understand. That this token was for that particular thing, and that's just for you to get used to it. Later on, there are technologies to enable these tokens to be stored by a ring, a key ring, and then you don't need to actually see them at all. You can have them populated directly by the key ring to the Git directly. You don't need to worry right now. So right now you save it. Okay, now you have got it in your desktop, so you can just go to the browser again. And then what you can do is that, okay, you have, now what happens is if you click anywhere else, then you can't see the token. Okay, so you can just click on, let us say, GitHub apps. Okay, just click on GitHub apps.
Yes.
Okay, now come back again, personal access tokens. Now you see that you have got a token there, and by default you can't see it, and of course you can delete it. Okay, you can delete that. Okay, if you want. Okay. So that's one way by which you can have ability to just revoke it. Okay, now let us say you have got a severe compromise on something where your GitHub passwords are stored and that laptop has been stolen or something, what you would normally do is come here and say revoke all, because you don't want your permissions on any machine at all. So therefore, nobody can use your GitHub access at all. Okay, that's one advantage. And of course, you can then create the personal access tokens as you like and keep using them. Now that long string is what you are going to use it as a password, basically. Okay, you don't give your own password, you give that long string as a password. That's a thing that I want you to know. Now once you have that idea coming up, okay, now next thing that we have to do is that we have to create a repository and start working with it. Okay, so click on your repositories. Okay, go ahead and you can create a new repository. So there's a button there, new. Okay, and give a name that your first part of the link is same. So just call it ID 2090 demo or something, because you are going to do something with this course as an assignment also. So just keep it as a demo. Okay, and leave it public. And let us say add a README file. Okay, and create repository. Okay. Yeah. So the now repo is created. Now don't have to do anything. Okay. Now what you should do is find a way by which you can replicate this onto your computer with the git command and start to edit. Okay. So what you do is you go to the command line. Okay, and choose a directory in which you would like to do these actions. Okay. So for that, what you do? Wait. What you do is first you make a clone of that particular repo. You are already making it as a public repo, so it doesn't actually ask a password. So you can type git, okay, clone, and then give the URL. Okay, give a space and give the URL of that particular git ID. You can go to the browser and actually copy it from the browser. Yeah. Come here and then paste it, and then in the end put a .git, because that would be the normally .git, demo.git. Yeah, demo.git. That is the name of the repo basically. Now enter and then see what happens. So it is already creating a directory. That's why I stopped you from creating directory. Okay? It's already created a directory. Now go to the directory. Okay, go to directory cd the ID 20 whatever. Yeah, enter ls, put ls, and now you see that there is a file that is there. Okay, now you have basically replicated the repository that was created on the github.com. Fine. Now you would like to edit it and push these changes to the remote, and therefore you are able to basically start working. So go ahead and edit it. Just a vi. Okay, readme.md. Okay, and just below that, just press O. Okay, added a line. You can say added a line from my PC. Okay, just to yeah. Now save it and come out. Now what you need to do is you have to basically configure this directory so that the Git understands that it's not any other directory. It is actually going to talk to the Git server. So what you should do is type a command git init. Git init. No. Git space init. 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 Initiation. Yeah. Okay. Enter. Okay, now it has initialized. What it implies by saying initialized is it actually has created a directory called .git. Okay, go and see what is in the .git. Go to .git, cd.git. Okay, and put ls minus la. And you see that it has created a whole bunch of things. Okay, it has created a whole bunch of things which are called as hooks, logs, objects, references, index, and whatnot, right? And so these are all branches. Okay, these are all basically the paraphernalia that Git will be requiring to understand which version you are working, etc. So don't touch anything. Okay, just come back. Okay, cd dot. Okay, cd space dot. Okay, so we don't always say don't kill percentage, kill space percent. enter. Yeah. So I just killed the see, when you put Control Z, it actually makes the program what was running become a background job, and that's not a good idea. So I just made you kill the background job. So when you say kill %sign, it means kill the background job. That's what is the meaning of that command. Okay. Anyway, now this one requires you to basically start working with your Git account. So you have to tell what was your remote machine, okay, and start doing some things on it. So what you do here is okay, tell that you have got that there's a remote server for it. So git space remote space remote space add, okay, and then space, and then you have to give a name for this. So let us say master, okay, and space, and master is the name for the remote machine, remote location of this particular directory, and you have to give a URL. So you already have the URL, so you can type that URL, okay, and enter. Okay, now it understands that there is a remote location that you have configured. Okay, now how are you going to talk to it? You should tell that. So for that, you should write git config, git space config, okay, minus global, two minuses, minus global, minus global, global, okay, space user dot name, okay, space, and in quotes you give your username.
Okay.
Okay, your username on the GitHub.
Yes, sir.
Okay, enter. Okay, now you don't need to give password because you are going to give it on the on the fly. But you should also configure the email because the authentication can take place using either username or email. So it's a good idea to tell that. So again, type git config minus global user.email. Okay, user.email, and give the user.email, not name. No, just go back a little bit. Yeah. Now email, and then in backspace, and then quotes, you give the email which you were actually configuring your GitHub account. What were email that you had, no, while registering? So that was the email that you were supposed to give there. Okay, gmail.com. Okay, whatever that email which you have configured basically. Okay, enter, and what happens is that from now on, whenever you do any action with respect to the remote server, it will actually check as if it is supposed to be done by Mamba Helsinki, and then it will check whether something has to be done or not. Okay, so now let us say git status. Okay, so it will check what is happening. Now you see that it has recognized that there is something that has changed. Okay, and you have changed your file. So you need to basically ensure that these changes are percolated to the server also, right? So what we do is we have to basically, before we push the changes to the server, what we do is that we have to note down what is it that I am going to do, like a message for the commit. So you type git add, okay, and then readme.md. Okay, just press R and then the tab, it will work.
Yeah.
Okay, enter. Okay, readme.md.
Yeah.
Okay, now it has staged. Okay, it is becoming ready for you to push that file to the remote server basically. Now you have to also tell what have you done. So you have to tell by giving a comment. Can you just hide that Google Meet thing that's on the screen?
Yes, sir.
Yeah. Okay, good. Now git commit -m. Okay, now in space, give a space, and in the quotations you write a message which is helpful. You can say modified from laptop, something like that. Some message to say what have you done. Okay, so that's a like a message for the changes you have done. You can say sometimes fixed some error or something like that. Okay, so enter. Okay, now what happens is that it is now noted down what files have to be pushed, and it has noted down what changes have been done. So it is ready to perform that. Okay, now comes the important part. Now, when you try to push, because the server is actually configured with you, it has to authenticate against you. So it needs a personal access token. So go ahead and create it and note it down and keep it ready.
Okay. Again, in
Yeah. Don't delete it. You keep it because your GitHub will work with the personal access token as long as you have it only there.
okay, should I create it now?
Yeah. Create it and leave it like that, because once you delete it, it means that you don't have access to it again. Okay. Yeah. Create one.
The same name or different?
Yeah, you can use the same name, not a problem. Yeah. Come down, create token. Okay, and copy it.
Yes, sir.
Okay, and come here, and to be safe, just type vi dot by pat.
Vi dot.
No, vi dot by pat. By pat. No, dot slash pat. What I'm doing is I am not asking you to store the password in the GitHub itself. Wow, that's very crazy. Then everybody in the world will know your
Yes.
password. So I'm storing one level up, so it is not available to others. So enter, and here you just paste it. I and paste it. I paste it here, and then delete the other one, so you don't actually get confused. Yeah. Okay, save it and come out. Sorry. Yeah, you have to escape and save. Okay, now I will tell you something for the beginners a bit easy to do. So when you are actually going to do the push command, it will ask for password and you need it readily. So you can say cat dot by pat. Okay, so enter it, and it is there on the screen. So you are ready to copy paste it. So now you say git push. Okay, and it knows where to push. So you just type enter and see what happens. Okay, you give the username.
Okay.
Yeah. Okay, and the password, what you do is you give this particular string, which is GHP whatever. Double click it on it and then paste it.
Yeah, please.
Enter.
Yeah.
So it has actually accepted your authentication. It has pushed the content. Now what you do is you go to the browser. Okay, and go to your repository. And you see that line has come up.
Yes.
So what you did on your server, on your machine, has now appeared on the server.
Yes, sir.
Okay. Now I will illustrate in the next session on how I can make a change and you can approve it. Okay. And we will also do it with each other so that multiple people can actually go and make changes so that all of us can collaboratively author some document. Okay, I will do that. Okay. So tomorrow's session, I will show you how to do that. So for now, this demo I hope was useful, so people can actually see what we are doing.